Morning, good afternoon, good evening, guys. Welcome back for the session CNP security. Today's topic, again, continuing topic of DMVPN, we'll be doing practical. Let me share my screen. So if you know, last time we did theory of DMVPN and I showed you how a hub is going to connect to spokes, hub to spoke, and then how spoke will connect their spokes. So hub to spoke and spoke to spoke. Now the question is why we should go for DMVPN. I told you DMVPN is nothing but dynamic multi-point VPN. It is going to give you ease of configuration. It is going to give you data confidentiality. It is going to give you data integrity. It is going to give you data authentication and anti-replay services. I told you about the replay attack on internet. So just because the infrastructure is internet and it is a shared infrastructure, it is not at all safe, secure. We are going to go for VPN, virtual private network. And just because it is going to become a little bit complicated, because we are not going to do multiple site-to-site VPNs. We are going to do hub and spoke, and we are going to do spoke to spoke. So I showed you that we have created tunnel interface because we are going to do DMVPN through VTI method, virtual tunnel interface. Virtual tunnel interface enjoys the same benefits what you have found in physical interface. Okay, they're same. And what is the good thing about virtual? You can go on creating many such virtual interfaces. Virtual. They are not physical. Okay, but definitely every tunnel interface needs an IP address. Every interface, in fact, every interface needs an IP address, layer 3 address to come up. So yes, my tunnel interface also needs an IP address to come up. That is, but I'm not going to use any public IP address. I'm going to use some private subnet. So as per my scenario in my diagram, you can see tunnel IP address is 10.1.1.1. That is the private IP address. On spoke router, that is R3, R4, and R5. Let me write it down that this is spoke 1. Okay, spoke 1 means R3. I'm talking about R3. Okay, you can say branch, you can say spoke, anything you can say. My spoke 2 router is R4 and my spoke 3 router is R5. I can go up to 200 or 1000 or 2000 also, but I just want to show how easy it is to configure these spokes. Okay, how important, how easy it is, and how the traffic is going to move, how the NHRP database looks. But I told you I'll be doing dynamic routing protocol between R1 and R3, between R1 and R4, and between R1 and R5. So yesterday we did, so this is a continuing session. Okay, let's go for 3 routers. Go to R1. This is an hub. Show IP INT brief. When I say show IP INT brief, I can see I can connect to my spoke router. Yes, I can connect to my another spoke router and 25. Show run. You see, I have also configured EIGRP. So in EIGRP, I advertised 192.168.10. That is my LAN. R2, I don't have to do anything because that's an ISP router. So I'll be doing everything on R4 and R5. So 3, 4, and 5 are the spoke routers. Okay. Now let's configure R1 for DMVPN. So let me just go with those commands. Okay. So on the R1, see again, you can do DMVPN with IC version 2 also. You can do VPN with IC version 1 also. Okay. So if you want to do DMVPN with IC version 2, that also you can do. Just check. Anyway, first we'll try to do it in IC version 1. So I'll say crypto, Izaki MP policy and some policy number. Authentication, shared, encryption, AES 256, hash, star 256, group 5, lifetime I will keep 86,000. Step 2, crypto Izaki MP key. 0 means not encrypted. Pre-shared key is Cisco address. I don't want to send my pre-shared key to one scope. I will be having many scopes. Okay. It will be continuously getting added. So I'm not sending my pre-shared key to one scope. Okay, that is why I gave the address 000. Now I'm going to make crypto IPsec, transform set, T set, ESP, AES, SHA-HMAC. The crypto IPsec, transform set, T set, ESP, AES, ESP, SHA. Okay. Then I say crypto. So if I'm doing with VTI method, then I will say crypto IPsec profile. See, you can make two profiles. Okay, you can also make IQ2 profile, but here I'm going to make only IPsec profile. So name ABC, set transform set, P set, exit. Then I'll create tunnel 0. The IP address is 10.1.1.1.255.255.255.0. Shut. Then I say tunnel mode IPsec IPv4. Tunnel source 12.1.1, that is public IP address. Then I will say tunnel key, some key 999. Then I will say tunnel protection IPsec profile and the name of that profile. So first I finish the tunnel configuration. I will set the MTU because the default MT is not supported. So I will make it 1416. Then I say IP NHRP authentication Cisco 123. IP NHRP map multicast dynamic IP NHRP network ID show run interface tunnel. Okay. Now also advertise this network. With the command network. Now spoke. Show run in spoke. This is going to be the same. Okay. You need to do EIGRP. Network 192.168.30.0. Network 10.1.1.0. Interface tunnel 0. IP address 10.1.1.3. 5.25.25.0. IP MTU 1418 or 16. Tunnel mode IPsec IPv4. Tunnel source 23.1.1.1. Tunnel mode here multi-point. Tunnel protection IPsec profile ABC. So this step is same except for NHRP commands. So let me explain you what is this NHRP command here with the command shown in interface tunnel 0. See, I gave the IP address to tunnel 0, private IP address. I said the default MT is not supported on tunnel interface, so I just reduced it to 1416. Now, I don't want anyone to come and query R1 for NHRP database, that is the public IP address. So I applied an authentication scheme between spokes, authorized spokes, and hub. That is, R1 is going to act as a NHRP server, R3 is going to act as a NHRP client. So I want only authorized, genuine NHRP client to come and query about NHRP database. So that is why I kept one authentication schema between R1 and R3. That is, R1 is hub, R3 is spoke. It has to be same between both the devices. IP NHRP map multicast dynamic means I said all this query process should be in multicast methodology. Okay. Then I gave one command IP NHRP network ID 99. Now it is like you have studied in CCNP switching, you studied about domain, and every switch who are participating in LAN network should be part of some BTP domain. You can have multiple domains. So it is similar to like the term domain. It is not exactly same. It is similar to domain. Here my NHRP network ID between all these spokes and all the hubs. Like, basically you might divide your world or divide your branches into some zones like Asian countries, East African countries, West African countries, European countries, like that. So your domain, your network ID will differ. For South Africa, the domain network ID will differ. For Asian countries or Asian branches, the network ID might differ. Or you can keep everyone in same network ID. So remember, network ID is not authentication. Authentication is separate. So every branch who want to participate in NHRP lookup has to be part of network ID 90. So I hope you are clear with this three terminology. Tunnel source will be some public IP address. Just because you have to change the tunnel as mode GRE multi-point. That means you don't have to specify the destination. See, when I said GRE, it came up because it was going down because I never mentioned the destination address. Clear? So you see, as soon as I change the mode, it came up. Because if you don't change the mode, what will happen? It will ask for destination address. I don't have one single destination. I have multiple destination addresses, R3, R4, R5. And in future, it will increase also. Now your spoke configuration is almost same except for few changes that you have to do it. One is you have to definitely your NHRP configuration will be same. So I'll just paste this. Just take a copy, paste it. So when I say show run interface tunnel 0, you see IP address is 10.1.1.3, MTU is given. Now, what is the significance? What is the importance of this NHRP commands? So IP NHRP authentication Cisco 0123, you know, it is nothing but authentication between R1 and R3. Then you have a term called IP NHRP map. See, basically, I gave you an example of just dial. I said you're standing on the road and you want to buy something in just dial. You have to query just dial and he will give you all the addresses. So I told you this example and one fellow tried to do that. But then later on he came to know that he don't have number for just dial only. So first you should know just dial number and then you query about your requirement. Like you want to have an ice cream. You're standing somewhere in the middle of the road and you're planning to have some ice cream of some special brand. And for that, you need to find out where is this ice cream parlor for this special brand. So you will ask them. But first you should know. So when I say IP NHRP map 10111, see, I am statically defining the private IP address of my hub, which is 10.111. That is the private IP address of tunnel 0 interface. And I'm also statically mentioning his public IP address. That means my R3 will never query R1 or the server for his public IP address. He should already know about this public IP address of NHRP server. NHRP means Next Hop Resolution Protocol. Spoke should know about hub private IP address, that is tunnel IP address, as well as his public IP address, that is called NBMA, non-broadcast multi-access IP, statically, not dynamically. Okay, like R3 want to know about R4, that is spoke to about his public IP and private, he can query R1. For other spokes, yes, he can query it, but at least he should know the server. So I told you one example. I said, if you're standing in the middle of the road and you want to have ice cream, you should know in advance the number of just dial where you're querying it. Okay. Next is IP NHRP map multicast address. You should tell him to send the multicast request to hub, that is 12111. That is the public IP address of NHRP server, that is my R1. I should always tell my spoke that who is their server. So NHS means next hop server. So I'm telling R3, my spoke, that your server is 10111. That is the tunnel IP address. So I hope you understood what is the importance, what is the significance of these commands. And I also gave you why I'm doing this command on VTI, that is tunnel zero interface. Now the beauty of this is, like, once I give this and once the tunnel is up, I will see my EIGRP is up. I should see it. My EIGRP should come up. But before that, the tunnel has to come up. Because unless the tunnel comes up, my EIGRP will not come. So let's see whether I have enabled my tunnel. My tunnel has to be there, perfectly configured with all these settings. And of course, I should have. So what I'll do, I don't need this route. Static route. Okay. Router EIGRP is important. Show IP INT brief. Show IP EIGRP neighbor. Show run pipe section router. The command we use to see EIGRP. So let's see step by step. Where is the problem? Troubleshooting. Always remember, in VPN, troubleshooting is very, very important. So always remember, check the phase 1. So what is the phase 1? Crypto ISAC MP policy AES 256. Good. Check R3 also. Show run. You see, AES 256 and SHA 256. AES 256 and SHA 256. Group 5, Group 5. 86,000 is the lifetime. 86,000 year also. Remember, lifetime need not to be matched on both hub and spoke. It can be anything. But haggle has to match. Haggle means at least you don't have to match L, but you have to match hash algorithms. I told you there are two algorithms to maintain the confidentiality of the data. We have encryption standards which encrypts the data. Encrypt can be decrypt. Remember, what is the significance? What is the importance of hash? Hash means the data is getting hash into some values. Always remember, hash values are being sent, not the data. Hash algorithms help to maintain the integrity of the data. Nobody can change your data. Encryption algorithms will hide your data. Nobody can read your data. Hash algorithms will protect your integrity of the data. Authentication will find out the identity of the other end, that is your peer. Clear? So IPsec profile ABC set, transform set, T set is there, tunnel interface, IP address is 10.1.1.1, IP MTU, authentication is there, network ID is there, tunnel source is there, tunnel mode is there, tunnel key is there, protection IPsec profile is there. Good. So this is also 1 minute. Let me just check. Pre-shared key is again Cisco, perfect. Transform set is again AES, ESP, SHA, HMAC. We did a copy paste, so not a big issue. Okay. Now we go and configure the tunnel interface. So 10.1.1.1, 10.1.1.3, MTU is there, NHRP authentication is there, NHRP map is there. Okay. Tunnel source is 23, tunnel mode, tunnel protection, IPsec profile. So when I say show crypto Isaac MP SA, okay. When I say show crypto IPsec SA, you can see the tunnel is up, but why my EIGRP is not coming up between the tunnel? So remember, EIGRP is following one important rule which was designed long back, some years back, split horizon. Split horizon, what is the meaning of split horizon? Whenever I am sending my network on an interface, I should not receive the networks on that same interface. So I have to say no IP EIGRP, or first I have to resolve this issue. What was that issue? Okay, I should say no IP next of cell, but first I will resolve split horizon issue. So I will say no IP split horizon EIGRP 10. Because see, as per the diagram, this is a single interface which is getting divided into 3 spokes. So whatever I have sent it on my single interface, I will not receive it with from the same interface. So I have to switch off my EIGRP. So when I say show IP EIGRP neighbor, still I can't see. I have to advertise my tunnel network also in EIGRP. Remember that. So if I'm not doing it, my tunnel network is already advertised. Good. What about R3? There is, okay. My tunnel network is advertised 192.168.30. So IP EIGRP neighbor, nothing is there. So run. My tunnel interface is up. Ping 23. 10.1.1.3. Debug crypto or debug EIGRP packets. Let's see if I am receiving hello packets or not. Not, it is sending it to the null interface. Tunnel source, tunnel mode, tunnel key, and tunnel protection. 4 components. See, what's the issue? Troubleshooting. Tunnel key is missing. See, neighborship is up. So what was the issue? I showed you the troubleshooting for this section, VPN section in DMVPN. So tunnel key was getting problem. Now you see when I say show IP IGRP neighbor, I can see R3 is my neighbor. So when I say show IP route, I can see this network coming in from 30. Now for R4, I'm going to use the same commands. I gave it for R3. So I'll go here and say show run. I can just do what? I can just copy, go to notepad, paste it. I have to change the IP address of the tunnel. Same. See, tunnel source has to be changed. Tunnel destination, I don't need it. Rest all my command is same for R4. I need to create router EIGRP 10 network 10.1.1.0 0.0.0.255 network 192.168.40.0. So when I say show IP route, I can see 30 and 40 is also received. I can also see 30, 40 and 50. For that, I have to do is what? I have to configure router EIGRP 10 network 10.1.1.0 0.0.0.255 network 192.168.50.0. So run. IP address is 10.1. Tunnel source. Why tunnel protection is missing. I made a mistake. So IP, EIGRP. So now you see my hub is having 3 neighbors, 3, 4, 5. My hub is having 3 networks received from 30, 40, and 50. But don't forget to give the command no IP split horizon. Whatever I receive on an interface, I will not give it to any other interface. Otherwise, see, when I go here, I can see 10, 40, and 50. If I remove this command on tunnel interface, no IP split horizon EIGRP 10. Or if I keep it, not remove it, keep it. Now what is the problem here? He will give only his network to this R3. See, he's giving only his network to R3, not giving others network. In fact, not giving any network to R4. Why? He's doing yes. Here you have neighborship. He is giving 10 network to this guy. So IP route. So you see 10 network is received by. So when I give this command on interface, tunnel interface, means I am switching off split horizon. So when I switch off split horizon, my R3 will get all the 3 networks. My R4 will get all the 3 networks. Can you see? Just because I said no. Now, when you see R3, you notice that every network that R1 is giving, he is giving with the next hop his own IP address. So, what is the challenge here? It's not going to be a good one. What if R1 is giving all the networks with next hop as himself? That is his default behavior. Is helpless. Then what will happen? Every time R3 will come and say, okay, come on, give me R4 or give me R5. You only said, na? Go to 30 network, to go to 40 network or 50 network, come to me. Next stop is 1011. Now give me. R4 also will do the same thing. Now you give me 30 and 40 network, 30 and 50 network. R5 will also come and say, come on, you give me. So many times, like, if if you buy something good, and then some people like that product and they say, oh, from where you bought? Say, okay, come on, give me money, I will bring it for you. So what is the problem now? Everybody start giving you money and you have to bring that product. So it is better you say, okay, this product I bought it from so and so mall. So if you want it, go to that mall. So the default behavior of my EIGRP is the next, only for EIGRP, not in OSP, that he gives next hop as his own IP address. So I have to say no IP EIGRP, no IP next hop self EIGRP 10. When I say this, you see, instead of 10,111 for every network, now you'll get exactly from where these networks are being taken. Like 40 network is taken from 4 and 50 network is taken from 5. So now my R1 is saying, okay, no, 40 network doesn't belong to me. It belongs to R4. 50 network belongs to R5. Same way, you see everywhere there is a change. See, 30 network belongs to R3. 50 network belongs to R5. This is, I'm just showing you for EIGL. If you are using OSPF, I don't think there is no issue. So these are the two commands that you have to give when you run the routing protocol EIGL. The two commands are, don't give the next hop of yourself. I'm telling my EIGRP, and please switch off split horizon rule, which says whatever I receive on an interface, I won't give it. So I gave you clarification of each and every command that I have used on tunnel interface, that is virtual tunnel interface. Okay. What is the first command to check the sessions? Crypto, show crypto, CCNP SA is the first command to check. Show crypto IPsec SA. Now the twist is, I want to, okay, very important. Show IP NHRP detail. See, R3 gave his private IP address and public IP address. What is the public IP address of R3? 23,111. What is the public IP address? What is the private IP address? So people will come and query. They are all dynamic in nature. People will come and say, okay, I'm looking for R4, that is 10.1.1.4. Because as per their routing table, 40 network can be reached via 10.1.1.4. But where is 10.1.1.4? What is the public IP address of 10.1.1.4? So when I say show IP NHRP detail, I will find my own static entry which I did it for R1. But I don't know R4 now. I don't know the public IP address of R4. So what I'll do, I will ping 192.168.40.1 via 192.168.30.1. See, my ping is successful. And what about my NHRP? You see, I got an entry that if you want to reach 10.1.1.4, go to the public IP 24.1.1.1. Now, from where he got this? From the server. And at the same time, show IP NHRP detail. You see, he also know about 3. Because see, for reply packet, he has to again consult R1 and say, just now R3 came to me and he was asking about 40 network. I want to return him. I want to reply him. But I don't know his public IP address. Because as per my table, I can reach R3 via 10.1.1.3, but I don't know his public IP. You can see he got this public IP address from NHRP server, that is R. And then both started communicating with each other. If I want to go to 30.1, my source will be 192.168.40.1. When I say show crypto, Isaac MPSA, I can see there are multiple tunnels. One is with 12.1.1.1, that is R1 permanent, and another tunnel I built with R3. 24 is the destination if 23 is coming. 23 is the destination if 24. So R4 will go to 23. So there will be, say, 3 tunnel being established. One is with R1 and there is a bidirectional tunnel. One is R4 and R3 and then R3 and R4. So this is temporary. Yeah? Now same thing I can do it with this guy also. I say I want to go to 50 network. See, I can go to 50 network. When I say show IP NHRP detail, I can see, okay, And this guy want to go to 192.168.40.1. Source is 192.168.50.1. So again, when I say how many tunnels, you see, show crypto Isaac EMP SA. Now see, one with R3, one with R4, one with R1. So 111 and one bidirectional tunnel. So here you will see show crypto Isaac EMP SA. Here you will see only 3 tunnels. Again, R3 wants to show crypto Isaac EMP SA. See, altogether 5 tunnels. Altogether 5 tunnels. Altogether 5 tunnels. R3 communicating with R4 and R5. One tunnel between R4 and you see the simplification of configuration. Only one set of configuration on each spoke. That's all. R1, I didn't do anything. R1 is having one set of configuration for all the spokes. Clear, guys? So I hope you understood the beauty of DMVPN. I added 3 spokes. R1, R3, R4. I added 3 spokes, R3, R4, and R5. One hub was there, R1. You can have a redundant hub also. In case if my hub goes down, my NHRP will get disturbed. So for that reason, I can do it. I hope you liked this session. I hope you understood what is DMVPN. I showed you with 3 spokes. I showed you one hub. We'll do DMVPN with IKE version 2 in the next session. Thank you very much. Bye. Take care.